whether it is critical manufacturing or industrial automation for any kind of production of equipment or production of any materials, whether production of commodities which we use every day, etc. This all gets covered under industrial functions. Then we see the role of ICS and SCADA in power and utilities, whether it is a power generation or a power transmission or power distribution. Power has three different functions. So all is handled by the industrial control systems and the SCADA control systems. Then we have oil and gas. So whether it's an oil, again oil has exploration, like what we have power generation, and then oil midstream, which is equal to transportation of gas, electricity. And then we have the refineries and various other oil marketing companies which are distributed across the country and globe. Then every organization, no matter we are in hotel or airport, etc., we always see the current generation building maintenance systems. They are all dependent on industrial control system and SCADA equipment. And then the transportation, whether we travel in metro or we travel by air or by today's general electric operated bus systems, etc., we always see industrial control system and SCADA in action. When we talk about the industrial control systems and SCADA systems, so typically these are the terms which you will see that are being discussed or referred to in the different conversations. And if we are trying to do the cybersecurity for industrial control system and SCADA, it is very important that we understand these terms to a greater extent, whether it is SCADA or ICS, that is industrial control systems, or IoT, Internet of Things, OT stands for operations technology. So everything which is related to the non-IT infrastructure of a manufacturing or a critical infrastructure gets classified under OT. Then distributed control systems, DCS, PLC, program logic circuits, CPS, cyber physical systems. So all these industrial PC, RTUs, field devices, IDV, historian, engineering workstation, and operator console. Typically, these are the building blocks of any industrial control system or SCADA systems. When these systems, they have to be seen in the, whenever we go and talk to the customers who have been actually involved in the engineering, operations, safety, etc. of the plant, they will understand them in different definitions called as level 0, 1, 2, 3, and 4. And this basically is a architectural distribution or classification of those assets and those terminologies that I've just described in the previous slide to be aware about. So we generally, the cybersecurity practitioners, when we talk to the plant or the refinery or the midstream oil or a power electricity distribution company, we generally see that they will talk about these terms, and they would expect us to understand, or everybody to understand, that yes, this is the different classification in which these devices are being put up. So this architecture is called as ISA 95, which was given to the world by Purdue University. So it's sometimes also called as a Purdue architecture, in which if you see those devices like DCS, like PLCs, PSCs, which connect to those end IEDs, RTUs to distribute the logic or the process information so that it can be automated by virtue of actual physical devices like safety valves or operation temperature gauges or pressure measurement instruments or the motors or the actuators that are giving the power or the motion to different components in the process of manufacturing or power distribution or power generation or oil distribution or oil generation. So those all get classified as 0, 1, 2. So 0 is absolutely the the field device that's non that's either electrical, mechanical, pneumatic, hydraulic, whatever it is, and then it gets controlled by some control logic, and that control logic will have some engineering information being sent to it. So that's sent by level 2 to level 1, and then level 1 operates the level 0 devices. Typically, these are on either on copper connections. That's most often what we see, using the physical wiring of RS-232 or 485. And also in the most last 20-25 years of plants, these are basically seen as the Ethernet communications. Then we have level 3 devices or information systems. These are basically the processing units or the information processing units, which actually bring in the human interaction with these machines, these program logic circuits. So that's what actually sits in level 3. And then comes the analytics, like SAP or ERP or smart warehousing. All those systems will come in level 4. You can further read is because this by inclusion of cybersecurity, now you would see something in the decimal also being talked about, layer 2.5 or level 3.5. Level 3.5 is typically where the IoT edge or the systems that are interacting publicly, but they are very much part of the plant OT or the ICS infrastructure. They are being placed in 3.5, and then 2.5 are like the system firewalls, which are going to now segregate the OT layer from the any kind of compute power of IT that is going to interact with that OT infrastructure. But this is more or less a generic representation by virtue of ISA 95 architecture. Now, when we see the next 3 slides, I'm going to give you some variants of how when you go and sit in the plant or in the this is just an example of a rig, which is inside, let's say, few kilometers inside the sea, used for oil exploration. So if you see, typically it will have 4 different subsystems, one for drilling control network, another for blow point prevention, which will find out what level it is, then dynamic positioning, which is basically for GPS and other coordinates to communicate and get the real understanding on oil exploration. And then obviously the entire ship needs to be powered. There is a powerhouse inside this particular rig, which need to provide the electricity to all these functions. So that's also another unit. And this is since inside the sea there is no wired, no fiber connectivity to the plane. So all the internet and the external communications happen via satellite communications. So I don't know how many of you have got a chance to go to the rig, but I have in one of my previous companies got a chance to. We were working for one of the oil gas company, and you'll have to be transported by a helicopter or a small aircraft to that particular place. So this typically is one kind of infrastructure that you see, which is not very common as what we see in our IT space. Then the same oil exploration company, when you come to their main center or any one of their refineries, you would see that you are you are seeing different networks. Let's say this part of the network is, for example, running the refinery tanks. Then you have this network, which is basically taking care of the PLCs. Then this is the other, or because refineries may have multiple systems, so this could be another subsystems. So if you see this system 1, this is basically based on a program logic circuits. And if the system is based on the distributed control like this, Then this is more of the closed loop systems. They also follow the similar structural programming, but basically these are more stronger feedback loop based systems where the automatic adjustments in the process happen, while in the PLC systems, you know, the human interaction is more. So that's a very basic difference at this level of the presentation. I would not like to deep dive further into these systems, but these are all there. So if you see these three blocks, they basically are connected on the serial communication, and then somewhere here, you know, this is where you will see that the Ethernet is there. So from the Ethernet, then it goes into uh, the layer 1, layer 2 distinction firewalls, which are basically 2.5, you know, what we call. And then we have various other human machine interfaces that are required to manage these infrastructure that are deployed across different sites or sub-sites within the plant. Then on the right side, you know, you could see that this is more of a new generation IoT infrastructure, and eventually on the top side, you will see that it even talks to the IoT SaaS providers. So this is a very common need in the large plants today. We've been dealing with our customers since last 3 years, where IoT penetration is very much there. It's not just that it's being talked in the presentations, it's really there. And the diagram actually which I've drawn here is basically very common in most of our customers, what we are seeing, whether they are in pharma sector or oil or electricity, you know, distribution systems. Then there's another infrastructure which you see most commonly, and that is basically a proprietary setup. So for example, this is one of the setup where you would see all the Siemens S7 protocol and its own specific switches are there to connect different you know, primary manufacturing division and secondary manufacturing division of some of the organizations. So primary manufacturing division in this particular case is 100% a proprietary infrastructure. So if you look at the last three examples which I have shown you, these are the various variants which you see across the plants. One which is totally inside the sea but needs to have an internet connectivity. Without that, there is no possibility of a communication. So there is the connection to external world is mandatory. Then if you come to the second, which is a plant, you could see a very cosmopolitan kind of infrastructure, which has a legacy on one side running on serial, getting converted on Ethernet, somewhere in cream. And then on the extreme right, you saw something which is basically a IoT setup. Then this kind of an example where you would see that the customer infrastructure has all the equipment that is proprietarily deployed by the respective vendors, the OEMs, like whether it's Mitsubishi, whether it is Yokogawa, whether it is Honeywell, GE, Siemens, or whatsoever, you know, you name, and they will have a very aligned to their own infrastructure stuff. So getting the information out of this will become one of the challenges, and the whole purpose of explaining this entire background was that. Now, if we see the current times, you know, all these organizations which have been manufacturing for many years, almost decades and decades, in the plants, or the organizations that have been generating electricity for many years, all of them have been challenged by the way the digital transformation is happening across us, with the new terms like Industry 4.0, smart logistics, smart factory, and manufacturing 4.0, etc. Over and above, all this is delivered by virtue of the new generation gadgets like IoTs, smart uh, tablets, and then we have wearables for human safety. These are all changing the game within the plants, and are basically making the evolution in the form of generation of new opportunities for the organization, or staying ahead of the competition for the organization. So this is a irreversible trends, and these IoT environments are very, very complex. They are adding sometimes, I remember one of the situations where we saw that one of the business process head has actually ordered the IoT infrastructure for the plant, for one of their business units which he or she was responsible for, and without even understanding that that organization which has supplied the IoT equipment requires the IoT edge that needs to talk to some Azure IoT or AWS IoT or Alibaba IoT, whatever they have taken. Analytics application was sitting in those SaaS clouds. So then, once having invested in that IoT technology, is when everybody started to do a reverse engineering as to how to incorporate that into the existing infrastructure of the plants. So these are various things which are happening because IoT use cases are very, very promising. If you see that one of the reports 2 years ago I was going through, I don't remember which of those big four companies or somebody else like McKinsey has published that report, that the landing gear of the aircraft, which requires titanium, the metal loss because of the wrong cutting is approximately to the tune of 20%, and it's a very expensive metal. I have got many chances to visit many metal companies, and if you walk across their multiple kilometers of campus, you would see the scrap of the metal lying left, right, center in many places. And if you see those scrap, you would figure it out that it is lying there for many, many years. And every scrap of metal which is lying there is basically a business loss. So IoT use cases are bringing those things much more into the spectrum of visibility, and trying to reduce these 20% kind of wrong cutting losses. So all these are very strong business drivers for IoT penetration inside the organizations. Now, if we see the COVID has added more ideas around the digital transformation. From a real-time, short-term perspective, currently our customers are talking about make our workforce work from home, and we want to run a plant with 1:3 shifts. So this is how most of those things are actually as a knee-jerk response. But in the midterm, what we see is, once the domestic manufacturing will revive, it will be by and large dependent on many remote infrastructure management based systems. And also it will bring in a lot of efficiencies because people will be, preferring to work from home and avoiding travel times, and trying to be able to collaborate sitting at home. So this is there. Also, in the long term, we see a concept of a dark factory, where what it means is that more and more robotic processes and cobots getting controlled remotely, and so on and so forth, taking care of these things. So both from short term, mid term, and long term perspective, you will see COVID is going to bring it'll act as a catalyst, to get the digital transformation in place. Because what people earlier used to say, no, I don't need this, I don't think so, we need this, are now actually talking about making these things happen. Now, under all these spectrum of the changes which we see across in the ecosystem of industrial control system, cybersecurity is definitely an enabler, as well as at the same time, it is a topic of discussion in the boardroom, in the plans, in the entire transformational journey which the organizations are envisaging for themselves. Now, when we get into the cybersecurity, we have to deal with the multi-dimensional conundrum. And what is this? this is basically having 4 different dimensions, and I'm sure that this is my individual personal view. If you talk to somebody else, he or she might bring in a 5th dimension to it or 6th dimension to it. So I am not trying to compete with anybody who might try to have a difference in opinion on this slide, but for sure there is enough to take us to home from this slide, and that I'm going to talk about here. So for example, when we have to see one of the spectrum of the problem statement when you start working on the on the cybersecurity is that the goals of the organization as to why exactly they are trying to do the cybersecurity needs to be very well known to you, you know, as a cybersecurity professional. And I see that if if we talk about only the knowledge which we have given or taken from IT cybersecurity space and try to paint it in the OT, it doesn't work. So we'll have to be aligned to their objectives. We need to understand the governance as well as business driver for they to be considering cybersecurity as one of the key fundamental that can actually change or make the change into their journey. And typically the starting point in at least 2 years ago when we 2-3 years ago when we started to see a big proliferation in this space was the IIoT journey. Then the brownfield, you know, we all know that today whenever we deal with the customers, we see that there is one plant which was constructed some 30-40 years ago. You know, you'll have to deal with those technologies which are legacy, and they are still very much there. And today they have another plant which is as old as just 2016 infrastructure. So if you see before 2008 in the OT space or the ICS space, most vendors used to have their own protocol, and there was not much of intercommunication which was possible between, let's say, one OEM and another OEM. Let's say if you have a DCS from Honeywell and you want to put a safety equipment from Yokogawa, it is very difficult if I have to imagine such situation in 2005. Today it is very much possible because in 2008 all these 31 vendors came across together and founded and launched a foundation called as OPC Foundation, where they started to work in collaboration with each other. So brownfield are a real challenge where you'll have to see the legacy. You know, we come across some systems where even it doesn't even have a Ethernet interface. It is only serial, and then if you see serial and that too, it will not support OPC. So you'll have to get the data out from that PNC or a pneumatic machine. So all that is what you need to be aware about in the brownfield setup. But as an organization, all plants belong to them. So you'll have to have a common understanding across the spectrum of IT and ICS space. Then on the other side, you know, the cybersecurity challenge is evolving. If we pick up last 3-4 years, we see the many groups which are actively engaging themselves into targeting the ICS and SCADA systems. So, you know, in 2015, 16, 17, we saw them targeting the energy companies. But now those skills which they have built over energy companies exploitation and the campaigns, they're trying to bring it to the manufacturing companies. And we saw one of the US chemicals company last year was being targeted. So this is another part on which you'll have to keep your eye on when you are getting into the space of ICS security. And lastly, most important thing, which most of you, if you have an IT security experience and just trying to embrace the OT security experience, is that the lifespan of OT equipment is at least 3 times more than your IT equipment. So, you know, typically a PLC or IED or RTU or any other infrastructure that is part of the whatever we have seen in the, you know, terminologies which we have discussed earlier, is typically having a lifespan of 15-20 years, you know, which is 3 times the IT and maybe 10 times the cybersecurity cycles. So this is the multi-dimensional conundrum, and then you're dealing with all types of attackers. You know, Here the attacker space remains same, so I don't have to very specifically moderate here to explain that yes, we all know that in the cybersecurity space we are possibly a target of state actors, or sometimes insider abuse, some script kiddies, who are just doing it for fun like teenagers. And definitely the cyber activism is there in the form of the activist groups. So whatever you see, in Ukraine happened in 2016, which was largely launched by one of those groups called Electrons. They created a very specific OT specific malware that's called crash override, that started actually infecting the relays, which is switch on and off of the grid circuits, and it actually started damaging them. And the damage means the replacement would take time, because I don't know how many of you got a chance to go on and see these transmissions, particularly in the transcos and the midstream oil companies. You would see that one of the unit where you have to actually visit is absolutely, for the diameter of multiple kilometers, you would not see a human being there. And then you'll have to handle with that. And it's absolutely sand or all forest or whatever, you'll see those kind of things happening. And in such places, if suppose imagine a relay goes bad, it's a very small device, in the transmission of power. But if it goes bad, the entire transmission line can go in that segment bad. So somebody has to replace them. So that's crash override malware was there. So all these organizations, or these these individual threat actors are targeting the same way they are targeting the IT infrastructure. And the techniques which they are using, and let me tell you, this is coming from, again, this is another slide which personally comes from my experience. So I would not like to say that this is 100% as is, what exactly is the reality, but it is very, 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 very close to what you see. So I would have studied in last about 3 years some 15-20 different campaigns, different attacks that have happened, and basis that I'm just trying to see that these are the very common techniques which have been used in those attacks. Remote administration exploitation, phishing, disrupting the equipment, and then, credentials abuse. We saw that first time in the multi-vector attack of Stuxnet in 2010, but it is often now. And then you see that most of the equipment is handled by technologies that support PowerShell. So malicious file or fileless through PowerShell is one of the common methodology in the post exploitation. So once the organization once the cyber criminal gets inside the organization, then to be persistent, or to move laterally, or to harm actually inside the organization other assets, these are the tricks or the tactics which are being used by the criminals in the past. Infected pen drive, again, one of the very common carrier vectors, and let me tell you, no matter how much you tell people not to use it, they will use it. And it's absolutely, imagine that a plant which is 4 hours on road from any nearest airport, okay, on that plant, and that's very common, 3 to 4 hours from the nearest airport is a very common example, at least in India subcontinent, where you'll have to travel 3-4 hours on the road to reach to the plant, and then getting into the machine which is down to start working at least will take many hours. Imagine in that case, connecting a pen drive is a very common need to stay in the continuity of operations. So it will also have an abuse. And then obviously the physical security breach. This is one of the very important attack vector, which we have seen in some of the attacks, which even happened in one of the oil companies last year, where the drone was sent, and then in one of the nuclear plants in our country. So many things happen around these vectors. If you would, or these techniques are being used most commonly in last 3-4 years by the cyber criminals against the SCADA systems. Now anybody would try to reason it out with me, that other than disrupting the safety systems or the equipment which we saw in Ukraine electric attack, most of these attack exploit techniques or the tactics, whatever I've shown on this slide, resemble that of IT. And let me tell you, that is true. If anybody would say that way, it is absolutely true. And you can do it yourself. You can pick up all the investigations of the last 3-4 years of cyber attacks. You would see that they will end up here. Now, why is this so? Because the most skilled cyber criminals, they come with the years and years of collaborative experience in the IT space. So they're very good at exploiting Microsoft, and Microsoft fortunately is being used in these SCADA systems extensively. Then they are very good in enumerating the Windows Active Directory. And let me tell you, Windows Active Directory is deployed and it's reality, okay, inside the SCADA systems. They are very good at exploiting the remote administrative VPNs. Now, let me tell you, VPN is a very, very important essentiality or a very essential need in these SCADA systems, because many organizations from Europe or from Japan or from United States or from some other countries have supplied the equipment that is sitting inside the plant in, let's say, which is 4 hours from any nearest airport in India. So if that is the case, imagine if that machine breaks down and you are supposed to deliver the end products by end of this month as a plant head. What would you do? You will allow remote administration, and remote administration is being used across the globe, and we know that the exploitations techniques are there. Then lastly but not least, we all know that these all equipments are being handled by some logic, and that logic comes from some kind of the file system in the form of some files. So you would see that the malicious files, etc., are the carriers. So all these techniques are there. The only difference you see in a SCADA attack as opposed to IT attack, while the starting point or the exploitation tricks might be similar, is that those individual fellows who are, or the syndicates that are targeting the equipment, they are very well versed of these SCADA systems. Once they reach industrial PC or an industrial engineering machine or an operator console on Flex or on or into some GE systems, they will be able to then walk inside the controllers. That's something which they know, but they don't need a controller DCS vulnerability, because most often I see that some aspirant who wants to work in SCADA security, he or she starts talking about researching on the Google to find out what are the known vulnerabilities in those GE, Yokogawa, Mitsubishi, or all those OT equipment. So please don't go by names. These are just names. I'm not trying to refer that. All of them have some here or there some kind of vulnerabilities. So those are not the one you're going to target, because they are not surface. They're not exposed to the hackers when you are trying to reach there. So there's no need to plan your simulations or penetration testings around that. Then what is the methodology that will work, when we go for a cybersecurity solution? So we've seen a conundrum. We have seen the different exploits that are there, and now since I'm trying to bring my focus to the cybersecurity solution, let me introduce you the 5-pronged solution strategy which we follow at QOS Technology when we talk to our customers. So first thing is that one has to have risk assessments done. And I'm telling you that when you'll see all 5, you'll say, oh, this very much resembles to NIST. This very much resembles to my ISO 27000. So what is different? Ramandeep is talking. So you'll see the difference in the subsequent slides. But the fact of the matter is that yes, these are currently absolutely the way you would see it in any other IT strategy. So you'll have to start with a risk assessment. Then you'll have to do a prevention technologies, and prevention technology, let me tell you, are no different than what are there for IT. So you're going to put a multi-level, multi-layer cybersecurity solution, which is basically going to segregate or going to inspect all the traffic that is moving inside the OT from IT surface. And that's where the 2.5 level is being taught, etc. Then we all know that there are many communication barriers which we come across in the plant. As I've already told you that there are many legacy things you can't actually prevent the security. So therefore, there has to be a system that should be able to detect any kind of issues in the infrastructure. And that's how the detection supplements the prevention. Then when we put a detection, we all know that in IT also, any detection is incomplete if there is no response procedures. So there has to be a response. And detection and responses, let me tell you, is a combination which we'll achieve in the OT space also by virtue of the logs which are being collected from industrial switch, or which are collected from industrial PC or industrial engineering station, or from the different Microsoft Active Directory or Microsoft machines which are there, or any other real-time operating system machines which are there serving as an HMI on this machine. So those logs will be collected, and you would need any big data engine to actually analyze those logs and also do a job of a SIEM. So you will see that there is not much big difference in these. And last but not the least, we have to talk about a resilience, the recovery procedures. How are you going to restore? Like in, the loss of cyber attack in the Ukraine 2016 December attack was not primarily because of the attack itself. It was basically the aftermath of an attack, because many relays, circuit breakers were actually being damaged, and resilience was a big issue, or the recovery of that took a lot of time, or restoration of power took a lot of time. So if you see prevention, detection, response, and resilience, more or less, almost to an extent of 80% in my experience, is same as what you plan for IT strategy. So therefore, it will not see much in my presentation next slides, because we are not going to talk much about that. We are going to talk about extensively on risk assessment and certain elements of resilience, which generally we don't do or validate in our normal engagements of IT security, but which we should, and my experience and our company's experience with many projects, which we have seen have to be part of our solution strategy. So prevention, detection, and response, I'm not going to cover much in the next few slides in the time left. So now let's start with the risk assessments. Risk assessment, again, in our strategy of going to customer, is further a 5-step process. So first thing is that we'll have to study the governance model. Here, it is very important to understand the customer's business. Not that you'll have to start manufacturing or start producing electricity or oil exploration for them, but you'll have to actually understand how they do the business. Because if otherwise we'll continue to just talk at our understanding of what we understand in banks and telecoms, how they are staying ahead in the context of cybersecurity. We'll just start trying to paint with the same map, while that's not true. So therefore, it's very important to understand what is their governance model, where are they operating, what are the nodal bodies they are accountable to. If something goes wrong in their infrastructure, and they are like an oil company or an electricity company, where all they are supposed to inform and update, all these needs to be known to you when you enter into the project to by and large extent. Then the second step which we do is we do a manual assessment, and manual assessments are typically a combination of a site visit, or you go and ask questions to the customers, or to the different stakeholders inside the plant, which have to cut across multiple business functions, whether it is safety, whether it is electrical, whether it is hydraulic, depending if the plant has an hydraulic engineer team, and then mechanical, and then you will come to the operations or the the control systems inside the plant. Once we have an understanding on the manual level, we know very much that how their network looks like. We need to bring in the tools. Let me tell you, there are two categories of tools which we have to use. One, the category of tools which basically are able to bring in the visibility in the assessment, and they should let us know how are these devices, level 0, level 1, level 2 connected to each other. Once they make a map, are we seeing any anomalies? Are we seeing any other issues to them? And I will show you that examples in the next few slides. So I'll not delve too much here. I will show you there. But the most important function here is that, let me tell you that you can't collect the data from each and every device inside the plant. So you'll have to smartly plan your tool assessment, and that would be done by very rigorous manual assessment exercise. So once if your manual assessment exercise is good, you would see that the tool-based assessment gives you a very well deserved output that you are looking for. And most subsystems, once you start understanding them from a manual assessment point of view, that okay, it is 30% Ethernet, 70% serial, or this is non-OPC, this is OPC, this is having a ring architecture, this is having a hub architecture, hub and spoke architecture. All those few things are there in your questionnaire, and once you see them, you will understand that every plant will have maybe 2 or 3 very high level diverse systems, and then most of the systems, they resemble those 2 or 3 types of subsystems, and that's exactly where your sampling assessment will come. And you will put your tool should collect the data for maybe 5-7 days, put together these 2-3 sample sites, maybe 2 or 3 days into each sample site. And then we bring in, at QS, we have been practicing for last 5 years, something like a purple team simulations, which is more or less like a red team followed by a blue team together working, and I'm sure that these days some organizations are talking about purple team. So we can have that session sometime later. But coming back to, we do a purple team tactics, and in that, basically we are doing the adversarial simulations. I'm going to talk in few of them in the next few slides. And eventually, to assess the resilience and the legal framework of the organization to whom they are accountable, what we have understood in the governance level, we are going to do a tabletop exercise in the form of a breach simulation with the technical as well as the senior management team. So whatever are our learnings from a manual, tool, and purple team assessments, we share those learnings with the technical teams and bring them across with the team on the management side, and we try to do carry that same purple team simulation in the form of a breach simulations. So let me deep dive that with you. So first of all, in our entire framework, or most of your even understanding, if you see, these are certain referential frameworks I would recommend anybody who is trying to do IT OT or a OT assessments. They should refer to at least this kind of a spectrum of referential understanding. Then the end should actually bring us this kind of an output. So for example, in the manual assessment, we will pick up, okay, what is the physical risk you would see? Yeah, we've seen some people plugging in USBs to the engineering workstation or to a HMI, human machine interface. Or sometimes we have seen even, I've seen people plugging in PLC directly to a USB port of a PLC, and that's actually risky, but obviously, as I told you in the beginning, that people see that it is the running of the plant which is more important than always cybersecurity being the top of the mind of an operator. So they are definitely going to do this. Then we'll have to see most plants see a OT LAN and IT LAN segregated, and there will be some kind of level 2, 2.5 firewall in between them. Sometimes it's not. Let me tell you, it's equally, you know, 50% of the times you would see, 50% of the time you would see it's not there. So therefore you will understand all this from the physical assessments, and then you will plot a risk model, you know, and this risk model actually is going to help our tool team and our penetration testing / purple team to actually understand what to go after, what to assess, what to validate, you know. So manual assessment therefore is a very essential component, and this risk surface which we understand manually, we share with our subsequent teams, which are VAPT team or purple team to be precise, and then they go. Certain things which are not there in IT, you would, you know, I'm sure if you will read through this slide, you would understand. If you come to the 1 minute, let me annotate. You know, this is a hexane group, okay. Then in the remote cultivate, I'm talking about parasite and elenite group. So these are few examples of the real campaigners who have actually targeted, you know, like say hexane targeted GPS. This, you know, which is this GPS system is basically used to actually give the time synchronization to all the machines, to PLCs, to field level devices, etc., to controllers primarily, and actually hexane targeted them. And if you see, we'll have to find out that what are the possibilities in the communications that can go wrong. Then goose is a protocol which is used in the electricity systems, you know, and this protocol, if you see in the current times, it is being ridden over by over let's say 4G, 5G, LTE. You know, these are the telecom technologies on which it is moving, and these technologies itself are, you know, a question mark on cybersecurity. So this is all what we'll have to see when we come across a system of manual assessments, that okay, how our analysts are going to do the next job. So then we, you know, also from the manual assessment, we figure it out that that where the tool have to be deployed, as I've already explained you. So once the tool is deployed, then you'll start finding such kind of things, you know, like 555 security alerts. So this is one of the samples. Okay, 4 process integrity alerts have been detected. So 22 assets. So for sure, this my team will go into each one of them and identify and understand what exactly is the OT surface problem. But let me tell you, this all is a OT surface problem, except for if you come across the situation that certain important points are to be highlighted, you know, like SMB version 1. We all know that this is a protocol which is used primarily in Microsoft, but you see 24 assets are using SMB 1. Okay, and then another is, if you see 1 point above this, the 5 OT assets perform data acquisition write operations on 17 PLCs. This is very unusual, you know. In the assessment exercise, when somebody sees that there are 17 PLCs which have been written by 5 OT assets, but yes, once you see all of them and you start investigating, some of them will definitely be the legitimate operations. Then we get this map in the tool. You'll start seeing that, okay, how can a level 3 directly talk to 1.5 or level 1 or 2 devices without even talking to 2.5. So all this basically becomes your anomaly detection components in your assessments. So once we finish a tool-based assessment, then we move to the actual penetration testing, which we in QoS call it as a purple team tactics. And here, let me tell you, we'll have to take the adversarial simulations apart from a typical penetration testing exercise. In a typical penetration exercise, you would see that your pen tester would have taken a surface of Windows exploitation, a surface of web exploitation, and a surface of any other, let's say similar system like a VPN, which most commonly are seen in the plants as the systems to start your gray box testing. But sometimes these playbooks are insufficient. Yes, they are the starting point, and it is very important that we should do handle them with this all objectives. But at the end of the day, we'll also have to see the other possibilities that we need to bring in on the table when we are doing the purple team tactics. And therein, what I will always recommend, and I would suggest, if you are going to do this exercise soon, study last 3 years 2 reports. One, I always promote, not that I'm promoting Verizon, but Verizon data breach investigation reports are very, very interesting reports because they bring in the real-time issues of last 2 years. You should read last 2 years report of DBIR. And then you also should read what are those last 2 years typical campaigns that have happened across the industrial control systems. Like for example, I've given some examples like Electron, Xenotime, Magnesium, all this. Then plot attack sequence. Today we have a very interesting MITRE attack reference model. Go there, figure out how can we actually demystify Electron, Xenotime, Magnesium, or any other similar attack sequences which you would have seen in your DBIR report or any other OT security report. Like for example, Dragos has a very interesting, they have been doing a lot of research for SANS and for many other organizations. So they publish report every year. So I solicit you can actually look into that report as well. So those reports help us understanding the attacker's mindset, and then you plan your blue team, your security controls, your alerts in the SOC, the incident response playbooks, how you would like to do it. And finally, you plan your tabletop exercise. So this is one example. All the blue is basically the security team, my security team's response to, for example, this Xenotime simulation. So when we did Xenotime simulation, we figured out this, and then these blue team recommendations came out very, very extensively. Now, this is not a typical penetration testing exercise, I'm sure, if you would do. This is more than that. So I'm sure that I don't need to tell the forum how to do a penetration testing because you guys are all well versed with. But this is something which I would recommend you should solicit your teams, or if you're doing it yourself, to actually look into, and picking up this kind of a attack. You should be able to create a simulation. In the simulation, you will be able to understand how your actual attack should be responded, and you will be able to fine tune your customers' solutions. Another example is Magnesium. Another way is that how our pen testing team, we bring generally these kind of flowcharts. I'm sure all of you would be doing the same way. Like for this is a real Magnesium attack simulation. You run this simulation in one of the customer's site, and you figure out that your controls were detecting, but the SIM deployed there was not doing the job. So my team came across these kind of correlation updates which are required on the Splunk or the SIM rules. What we generally do is, because we work with certain SIMs, and getting a knowledge of all 18-20 SIMs across the globe is not possible. So for example, my team, first thing they do is they immediately write a rule on Splunk, and then I take that and transform that through other team members in our team to do it into any other SIM which is being deployed. So here you will see the SIM rules for when we finished a Magnesium simulation in our customer, this is what it resulted into. Then, so this is my last slide part, which is basically carrying all this, whatever we've learned from the cyber simulations to now the breach simulation. We The cyber simulation is basically for a technical team. You know, when you simulate a attack or a penetration, and then you see how your blue team tools or how blue team processes are responding. But when you actually have to take that to one level beyond, assuming that there is a breach, assuming that the same magnesium or xenotime kind of a breach will happen, or electrum breach or parasite breach will happen at your organization or this customer organization, how are you going to make people understand and collaborate with each other? So that's basically done by tabletop exercise. So imagine that in the previous step, we have already finished a technical exercise. Now we are actually expanding ourselves to do a tabletop exercise. Sorry, tabletop. It's a typo error. It's a tabletop exercise, and we choose the same subsystem. And in the subsystem, technical teams are now aware about what gaps they have seen in there by virtue of the tool, by virtue of the VAPT exercise which we have done in the form of a purple team tactics. Then they also bring in the second step the understanding of what regulations and compliances they are bound by as an organization. And everybody studies that, because I'm sure that if I ask a technical team question, most of the technical teams are not aware that whom to respond to, or what are we supposed to do if we see any kind of a breach in the form of a phishing or a directory enumeration or Experian AMS, DDoS. So where should we go? Whom should we understand? So all these processes are being studied in a tabletop exercise. Then in the third step, we circulate the best practices of communication, that in which roles are being played by the real role players. You know, like a IT manager will play a IT manager role, a security plant manager will play a safety manager role, and then the CEO will play a CEO role, CIO will play a CIO role. But we will create some role models. You know, smart people will create somebody as a media journalist, will create somebody as a corporate lawyer, PR personnel, you know, who are not very clearly seen in these organizations. And in the last step, we actually run one sample of the same breach, that this breach has happened. This has compromised your, let's say, the power distribution system in this particular SRLDC. So go, and now how are you going to face the customers? How are you going to face the media? How are you going to face internally? What kind of data you're going to collect? All these are being done as a tabletop exercise of about 4 to 5 hours of workshop. And let me tell you, these are very amazing workshops. There are many new things which these guys learn and we carry. So on this slide, I will end that typically a cyber breach is something which is a reality. And even if it is not happening to the organization, then someday if it happens, how are you going to respond to it is a very important fundamental which you have to be aware about. So what we are doing in QOS, you know, for just last 1 minute, I would like to talk about QOS, that we have built this all simulations for our customers to practice, you know, in the form of our cyber range, which we call in QOS as purple range. It is currently deployed in our Bangalore labs, and very soon, in next 1 quarter's time, we're going to announce this on a SaaS platform, where instead of doing just this as a complete tabletop exercise, we are actually going to do it in a more like an automated COM simulator, you know, communication simulator. So COM simulator stands for the communication simulator. And I thank you all for coming in the morning to be part of this discussion. I have a couple of questions. Let me see if I can open. I'm not sure how to open these questions. Yeah. There's one question: how can we achieve east-west traffic control between PLC 1, 2, and DCS 3, which connect back to the gateway? Excellent question. The only way you can control one subsystem or one PLC subsystem to talk to another PLC subsystem is by virtue of microsegmentation, and those are nothing but the small security gateways which are deployed, they have to be ruggedized because they have to handle all the plant conditions. Second question, in the current context of digital transformation, most organizations are gearing up for zero trust journey. And in addition, the collaboration between the IoT vendors like Clarity, Nozomi, CyberX, and security vendors like Palo Alto, Checkpoint has enhanced more visibility and automation of the IT and OT convergence. This is the scenario. Thanks a lot. It's a big question. How many more control layers do we need on the top of it? For the instance of adopting the SDP, I'm not sure what does it mean. If it is something to do with software defined platforms with respect to microsegmentation, are we looking for API integration points? So my answer is that yes, it will be both. You will be with the more and more proliferation of IoT and other digital platforms like robotic process automation. Typically, we see that in the modern manufacturing units like that of cars manufacturing or truck manufacturing or electric vehicle manufacturing. Therein, you would see that there are going to be the API security gateways. While in the previous answer, I have already explained that yes, at the end of the day, as much as you can go closer to where from your Ethernet is starting. See, serial is absolutely safe. Wherever the RS485 is coming or RS232 is coming in the plant, I don't say that you need to go up to that level of securing that, but wherever it gets, translated to something like VNet or DNP3 or any other Ethernet protocol by virtue of some converters or mediation devices, you need to start looking from a cybersecurity at that point. Because imagine if below infrastructure is not able to digest any kind of an issue in the wrong command given to a DCS. And if any wrong command given to a DCS which is running on serial, let me tell you, you will, no matter whatever you will do, you sitting in the plant, you will never be control room, you will never be able to get the visibility of that so easily. So all that is very important. API security and software defined security both is going to be the order of tomorrow, but may not be right now, because there are many low hanging fruits which OT security has to consider right now. Second corollary of the question is, and would it not be cumbersome to manage? Yes, of course it is going to be cumbersome, no doubt. That's why I'm saying we have to firstly start with the lowest hanging fruits, which we have already started today. Let me see if there is any other question. No more questions. Thank you very much, folks. I really appreciate your joining this session in the morning of today, 18th August. Good day. Thank you very much.